So today we're going to talk about more facts about parallelograms. If you remember in problem number 13 from last night's homework, we did a proof. And the proof proved that when you had a parallelogram, you have diagonals that bisect. So now we have a theorem that states that. So basically what I'm saying is, anytime you know you have a parallelogram, no matter what its shape or orientation, and this is a parallelogram by definition, if I draw the diagonals will bisect each other. So that diagonal is cut into two equal parts, and that diagonal is cut into two equal parts. Might not look like it based on my hideous sketch, but that's the truth of the situation. Always, two diagonals will bisect each other. The diagonals will bisect each other in a parallelogram. Yes, ma'am.
Would we just call this diagonals of a parallelogram?
So basically, if you had to use this in a proof, what I would say is, in a parallelogram, diagonals bisect. Or diagonals bisect in a parallelogram. Just write it out. All right, so this leads us to some very useful techniques for solving stuff. In this particular example right here, we know we have a parallelogram. We are tasked with finding the value of Ln and Km. Well, the geometry of the situation is, since it's a parallelogram, the diagonals bisect. So this is what I mean by showing your work. You would start out by saying, hey, what does this mean geometrically? And geometrically, since the diagonals bisect, those two individual segments are going to equal each other in the diagonal Ln. And in the diagonal Km, we know that Kp will equal Pm. Now we can use the magic powers of substitution and turn this into an algebra problem. X equals y plus 2, and y plus 10 equals 2x minus 8. Now we need to know what the variables equal so we can find out what the segments equal, so we can add the segments together to get the length of the diagonals. Well, we've got two variables. That could cause a problem, except for the fact that we've got two equations. So this is a system. How do you solve systems of equations? You've got basically two tool sets you can use. You can do it by substitution, or you could do it by elimination. Technically, I guess if you wanted to and you had a graphing calculator, you could graph both lines and find the intersection, and that would be solving the system by graphing. But probably at things this simple, we won't do that. So, and really, if you don't have some sort of computational tool to use, solving by graphing is not very efficient at all. Which one would you use, substitution or elimination on this one?
Substitution.
Why?
Because x, it just gives you x.
Right. This one is already solved for x. This is a great problem to use with substitution because half the work is already done for you. So everywhere I see an x in this equation, I'm going to replace it with y plus 2. So I don't replace the y, I don't replace the 10, but I do replace the x with y plus 2. And one of the things I usually do to make sure I don't make a mistake is I take the variable that I'm replacing and I make parentheses, and then I fill in the parentheses with what the variable equals. All right, and so here I'm going to distribute. That's 2y plus 4 minus 8. There's a process I go through when I solve an equation that's got a lot of steps to it. I always distribute first. I always collect and combine my like terms second. So plus 4 minus 8 is a minus 4. Here's something that I do a little bit different than a lot of my students. I always get the variable on just one side of the equation before I start subtracting the numbers, because to me that adds more flexibility. So I like working with positive variables. I'm going to subtract y from both sides of the equation. So 2y minus y is what gives me the y. And then now it's really obvious that to isolate the variable I need to add 4. So y came out to be 14. And then if I go and back substitute in, if y is 14, then 14 plus 2 is 16, and that solves for x. So I've solved for x and I've solved for y. But now I've got to do what the question asks and find Km and Ln. Well, LP will be 16 because we solved for LP is just x, and we solve for that. PN must also be 16. And so LN is just going to be the sum of those two. So LN would be 16 plus 16, which would be 32. Everybody okay with that? And then KM is going to equal KP plus PM. So KP is y plus 10, which in this case is 14 plus 10, which is 24. And since those two are equal, the other one has to be 24 as well. So 24 plus 24 is 48. So Km is equal to 48. So our two answers are 32 and 48 respectively. Everybody okay with that? Any questions about what I did? All right. Do you have questions about this one before we move on? Or do you think you need some practice? And that's fine. That's perfect. So let's practice. What I want you to do is I want you to find the value in parallelogram PQRS. And then I want you to find the values of x and y. And then after you find x and y, I want you to find PR and SQ. And I'll go ahead and make this picture a little bit bigger so it's easier to see. And then I'll let you go ahead and work with your partner on it. So this will be a collaborative task. And you can go ahead and begin. So we're trying to solve this problem right here. We're trying to figure out the lengths of PR and SQ. And we know that we're dealing with a diagonal. So what do we need to do to set this up? Put what equal to each other? So what you're saying is not wrong. I would prefer you start out by creating an equation using your geometry facts, PTTR, and then substitute in ST, TQ. So what you were saying was 3y minus 7 is equal to 2x, and x plus 1 is equal to y. So we now have systems of equations, two variables we can solve. So kind of going with the reasoning, does it matter which variable you solve for first?
No.
What would probably be the most easiest variable to solve for first? Why?
Because it already gives what
Yeah, y is already isolated. Technically, that means we're going to be solving for x first, because when we put this in for y in the other equation, we're only going to have x's, and we'll get an answer for x first. And then we'll back substitute to get the answer for y. But I got what you were.
Wow, I didn't understand it, but no, I did.
Okay, so since I'm substituting in for y, what I'm going to do is I'm going to go over and where there's a y, I'm going to put parentheses. I'll write out everything else. And then inside the parentheses, I'll put what I'm substituting y with, the x plus 1. So 3 times x is 3x, 3 times 1 is 3, minus 7 equal 2x. Collect and simplify my like terms. 3 minus 7 is a minus 4. Just because this is how I want to do it, I think I'll subtract 3x from both sides. And then multiply both sides by negative 1. 4 is equal to x when I isolate x. And then I'm going to go back and I'm going to put in 4 for x. And now I can find the value of y. Okay, so once I know the value of x and y, I can go back. So this is one answer and this is another answer. Now I'm going to go back and substitute those in for the individual line segment lengths. So PR is equal to PT plus TR. And so that's 3y minus 7 plus 2x. But if I substitute in further, that's 3 times 4 minus 7 plus 2 times 4. Oops, should be 3 times 5. You're going to substitute in the right numbers. So 15 minus 7 is 8, 2 plus 4 is 8, 8 plus 8 is 16. We would do the same thing. Q is going to equal ST plus TQ. By the way, what property am I applying right there when I make that equation? That's right, the segment addition postulate. And so by applying the segment addition postulate, this was x plus 1. Well, x plus 1 is just 5. And this was y, and y is just 5. So 5 plus 5 is 10. So there you have it, your 4 answers that are required for this problem. Does anybody have any questions about what I did or how I got what I got? Or why I used substitution? Would it have been wrong to solve for x and say x is equal to y minus 1 and plug it in a little bit differently? Nope, you'll still get the same answer. All right, so there's another theorem that we're going to talk about, and this is kind of an extension of using parallelograms over and over and over again. If I take a series of parallel lines, and I draw a transversal through those lines, and I find out that those parallel lines cut that transversal in equal parts, every segment of that transversal that's cut by the parallel lines is congruent, then it's telling me that no matter what transversal I draw, all of its individual segments will be congruent to itself as well. So what I'm saying is I had 3 parallel lines, and I drew ACE or AE through it, and AC and CE are congruent. It divided this line into 2 congruent parts. So any other transversal I draw, no matter how I angle it, will also be divided into congruent parts. So, and that's no matter how many transversals you draw or how many parallel lines you have. So here's 4 parallel lines. If I draw a line right here and mark all of these congruent, oops, I got carried away with the congruency. And then I draw another steeper diagonal right here, then these segments will all be congruent to each other as well. And if I draw a line that's even steeper than all of that, then all of those parts would be congruent as well. So let's apply that. So in this particular problem right here, I've got line segment AE parallel to BF parallel to CG parallel to, there's supposed to be an H down here, DH. And I know that AB equal BC equal CD equal 2. So I know that all of these are equal. I don't even care that it's 2. I just know that they're all equal to each other. So that means that all of these segments will also be equal to each other. So if I tell you that this is 2.25, what do you know about the other 2 segments? They're also 2.25. And if I want to know the length of EH, well, it was just, there's 3 broken pieces of that segment that are all 2.25 in length. So 3 times 2.25 is 6.75. So I can find the value of EH by knowing one of these segment lengths and knowing that all of these are congruent, which makes all of these congruent. Everybody okay with that? Good. You do it. All right, so in this particular problem right here, what you should have realized is that all of these are congruent, which makes all of these congruent. And so if these were like each a value of x, and the distance from here was 15, then basically 3 x's equal 15, so x is going to equal 5. The distance of one of them would be 5. So that's how long this is it's 5. And that's basically the way to do it. So homework for tonight, you can go ahead and get started on it.